Good morning, everyone. Last time we have completed the last chapter that is called the periodic classification. This time we are starting new chapter that is chemical bonding. Chemical bonding, when we start with the basic concepts. Then first of all, why any system undergo the bond formation? Why any system undergo the chemical reaction? Initially it was said, seeing the periodic table, that almost all the elements are reactive except few of the elements, that is the helium, neon, argon, krypton and xenon. And what is the uniqueness of these of the elements? What is the common in these of the elements? Except the helium, all these of the elements have the 8 electron in their valence shell. And it was said that having 8 electron in the valence shell is the criteria is being stable. And this rule was called octate rule. So according to octate rule, all the elements undergo chemical reaction, undergo bond formation to complete their octet. In the process of completing their octet, they either share the electron, they are transfer the electron, accept or donate the electron, or sometimes they share the electron in one way. That means only one of the elements donate the electron or the share the electron, next one only accept that shared electrons. So here we are going to discuss about these of the different way of the chemical bondings. Before that, a scientist says that how these of the bonds can be explained, and for that he gave their own theory, and this concept, this theory, whatever it is, this concept is called the kossel approach, on the name of the scientist who gave the approach. So according to Kossel and Lewis, all the elements must be written with their valence shell electron. That means whatever the electrons are there in their valence shell, that is the outermost shell, that must be represented with each and every element with their atomic symbol. Here I am writing some of the symbols, that is the lithium having one valence shell electron, beryllium 2 valence shell electron, boron 3, carbon 4, nitrogen, oxygen and chlorine. So in this way the elements should be represented. Generally we call it electron dot structure, or on the name of the scientist we call it the Kossel-Lewis approach. So on the basis of the Kossel-Lewis approach, how will you explain the different bonds and the nature of the compound we are trying to find? And we are starting with the ionic compounds, that is the electrostatic bond. How the electrostatic bond will be formed, and which type of the compound, which of the type of the elements forms the electrostatic bond. The electrostatic bond is prepared in between those of the elements which have a big electronegativity difference. One is electropositive, one is electronegative. Only in that condition the electrostatic bond is formed. That means one element is going to donate the electron and next element is just taking those of the electron to make the ionic bond. Here I am taking example of the sodium chloride, that is the NaCl. Here we are taking sodium and chlorine atoms. Sodium having only 1 electrons in their valence shell, electronic configuration 281, and chlorine having 7 electron in their valence shell, having electronic configuration 287. That means chlorine need one more electron to complete their octet, and sodium need to lose a single electron to get a complete octet condition. In this condition what happens? The sodium donates the electron to the chlorine, and sodium gets a positive charge over it and chlorine gets a negative charge, and these of the species having opposite charge attracted by each other, and because of that attraction they combine with each other forming NaCl. and such type of bond are called the electrostatic bond. Even some of the scientists says that it is not a chemical bond. It is just a attraction force in between positive and negative charges. Why they say that this is just a attraction force? Because when you will see the species, there's no any directional nature. That means the bond is non-directional. You can't identify that there is any direction in these of the molecules, and because of the reason we can say that the bond is not a chemical bond. Even at this time I am teaching as a chemical bond here, but in the next topics whenever I will talk about the chemical bond, that here is a chemical bond, there is a chemical bond, this is the property of the chemical bond, in all of those of the cases I will just talk about the covalent bond. I will only talk about the sharing of electron. I will not talk about this type of bond, that is the ionic bond. But at the time I am talking about the ionic bond and I am taking it as a chemical bond. When we see the nature of the ionic compound, that is the compound which is found by the electrostatic bond, then what type of the nature will be there? You can see I am just drawing the structure of the Nacl lattice. Actually I am drawing in only 2D at this time. This is the sodium having positive charge will be attracted by the negative charge, and the chlorine having negative charge will be attracted by the positive charge. In this way they are attracting each other and so on. And when you will see the next dimension, this is the next dimension, that is the sodium is combined with the chlorine, chlorine with the sodium, and again chlorine and again sodium, and same in this row. And these of the elements are combined with each other, forming a 3D structure. I am not drawing the complete 3D structure, but this 3D structure, this arrangement is called the lattice. So these of the systems are generally survive in the form of the lattice. Again in the lower plane there will be the condition. I am seeing a specific element, I am taking this one. How many bonds are there? The first bond, this one, second, this one, third, fourth, fifth and sixth. There are 6 attraction forces working in between around the sodium. लेकिन इनमें से कौन सा एक्चुअल केमिकल बॉन्ड है, क्या आप बता सकते हैं? Surely not. And this is called the non-directional nature of the ionic bond. Same in the case of chlorine. 1, 2, 3, 4, 5 and 6. यहाँ भी आप ऐसा कुछ नहीं बता सकते. That means when you will see the ionic system, they don't have any directional nature. But what will be the property of these of the compounds? You can see a very strong intermolecular forces are working there. The atoms are arranged in a perfect geometrical structure, and with these of the condition, system must have a very high boiling point. Boiling as well as the melting point, especially the melting point. The system have a rigid nature, that means that is not going to change their shape. Something like this chalk. If you are trying to change the shape of the chalk, you can't change the shape. But if you will use some excess of force, you will find that the chalk is broken. That is not changing their shape. That is opposing the change of the shape in that extent that can break, but that is not going to change the shape. This is called the brittle nature. So these of the substances have high boiling and melting point, brittle nature. They are very much rigid. They have very sharp melting point. For example, if you are taking any of the amorphous substance, what's about their melting point? They melt. Generally we say that during the change of the state there is no change in temperature, it takes place. But the second law of thermodynamics says that the complete conversion of energy from one form to another form is not possible. When you are giving heat to the system, whether the complete heat can be converted in the form of the molecular kinetics? Surely not. And if that is not converting in the form of the molecular kinetics, what's about the remaining heat? What was not converted? that heat will come out and that will increase the temperature. So if that process of the melting is taking time, the temperature will increase. Surely that increase is very nominal, though the increase will take place. You can see the amorphous systems, the non-ionic system, covalent system in the form of the ghee. आपके घरों में जब घी को मेल्ट किया जाता है, उसको मेल्ट होने में कुछ सेकेंड्स लगते हैं, और ऐसा होने पर उस समय में हो सकता है थोड़ा सा टेम्परेचर वेरी करता हो सकता है नहीं, करता है. that is the range of melting point. Even that range is very small, though that is the range of melting point. But when you will see this species, that is the ionic species, you can see that all the attraction forces are the ionic. That means very strong attraction force, that is suggesting that the melting point will be very high, and all the attraction forces are identical. That means at the same temperature, that means the temperature at which this bond is going to break, the same temperature will be needed for the breaking of this bond, this bond, this bond, this bond, and this bond. That means with the same temperature all the bonds will break, and that will be the condition like the exploding condition. वो explosion सा हो जाएगा. And this is the reason हिंदू घरों में कहा जाता है कि नमक को आग में डालना एक अपशगुन है. This is the reason, because if you will put the salt in fire, that will break and that can generate an unpleasant condition. And in the modern days we are using the powdered salt. In the time when we used to create such type of the rules, at that time you know that we were not using these of the powdered salts, we were using the crystals that can damage even more. And this is the general property of the ionic species, and this is the reason why we are saying that don't put the salt in fire, that can create some unpleasant condition, that can create some accident. So this is the chemical property or the physical property of the first type of bond, that is called the ionic bond. What is the type, how the bond formation is taking place? The ionic bond formation takes place by the shift of electron. In the next video we will discuss about the covalent bond, and we will discuss about the next type of bond what you have not studied till now, that is the coordinate bond or the dative bond with other property. Till then, bye, have a nice day.